In section 8.6, we're going to take a minute and just recap all of the analytical methods that we've gone over to integrate. All of them. There have been a lot. All right, so first of all, you have your basic integral rules. That's that quick integral reference sheet that we have from Calc 1, and we're allowed to use, of course, in Calc 2. Then we have substitution. I shouldn't really call it U-Substitution because technically it can be any letter you want, and we'll often use other letters like V or something like that, but it's substitution for sure, and it's usually U-Sub. Then we have all of your favorites, all of the algebra and pre-calc techniques that you have learned. And there's a ton of them. You learn them in Calc 1, but they don't really sink in at that time. But you have expanding the numerator, you have separating the numerator, you have multiplying by 1, completing the square, dividing improper fractions. That's polynomial long division to you and me. All of them. There's so many of them. so many. All right. Basically every trick you've ever learned in algebra to modify a function, you can try. Every single one of them. And then integration by parts, we learned in section 8.2. The trigonometric identities, of course, we actually learned in pre-calculus, but they're also still useful. And we also use them in this chapter. And then the reducing the trigonometric powers with the power functions. Don't forget your reduction formulas. We also have those. Then everybody's favorite, trigonometric substitution and partial fractions. Now, a lot of students, they get frustrated with performing integration analytically because they don't know where to go. You know, it's like, oh, I don't know where to go. And the answer is you persist. You keep going and going and going. You try something else. You have a list here of about 16 different things to try. You try them, you work with it, you play with it until you get something that's useful to come out and shake out of what you're doing. So if at first you don't succeed, you're running about average. And most people don't succeed when they first look at a problem like these. So this is going to be a very tough section in many ways because even though it's a review section, you're putting it all together and you'll have to analyze the problem and kind of figure out which of the many techniques you have you want to use. Okay, so let's start with some. So here we have e to the x over a squared plus e to the 2x. Don't we love it when they put a in, where a is a constant? And it doesn't say that, but it's always assumed. You know, a, b, those kind of letters are usually constants. So note a is a constant. All right, so you look at this and you want to think about, what could I do? Well, I think we could use U-Substitution. No, I'm not kidding. We could really use it. Okay, so here's your U-Substitution. U is e to the x. Bear with me here. Du is e to the x. dx. So if I think about my problem here, I have 1 over a squared plus e to the x squared, right? So this is u squared. I guess I could just make a note down here. E to the x squared is e to the 2x, right? You don't really think of it that way, but it is, right? And then you have your du. All right, so then that should be setting off little bells in your head. You know that one because it's on your quick reference sheet. It's right here, right? So it's 1 over a arctangent of u over a. So this would be 1 over a arctangent of u over a. Plus c, of course. And that was with formula number 19 on that sheet, all right? And then we would just put back in u and we're done. So this is 1 over a arctangent of e to the x over a plus c. All right, so let's think about the techniques we used. The techniques we used, oops, if I could spell the word techniques, there we go. We used substitution, and we used our quick reference sheet. And I keep saying quick. You might be wondering why, and it's because there's another one coming in about another section or two. I think it's the next section. So there'll be more coming, I promise. All right, so let's look at the next one. Well, when I first look at this, I'm thinking maybe I should just FOIL it out, see what I get. So algebra, right? All right, so this is integral of secant squared of x minus 2 secant of x cosine of x plus cosine squared of x dx. Well, the integral of secant squared is no problem. The integral of secant squared is on our sheet, so that's easy. Secant cosine, well, I'm thinking about switching that around to like 1 over cosine, right? Because secant's 1 over cosine, so. All right, so let me write this. This is secant squared x minus 2, and then I'm going to change that in the middle. This guy right here is going to become 1 over cosine of x times cosine of x plus cosine squared is, there's a half angle identity for that. Cosine squared is, so this is the half angle identity, and this was the secant identity. So I'm using two different trig identities. Cosine squared is 1 plus cosine of 2x over 2. And the half angle is the fact that this is cosine of x and this is cosine of 2x. The angle here is half of what it is there. So that's the half angle identity. Okay, so this is the integral of secant squared of x. Again, this one is going to be no problem. We know the integral of secant squared is tangent, so I'm just holding off. Technically, you can do it right now and say tangent and then start your integral sign over here if you wanted. On this one, this cosine here and the cosine here are going to cancel, and you're left with minus 2. So that's nice. And then I'm going to split this numerator. So this is plus a half cosine of 2x. And then I could combine these two together. So this is the integral of secant squared of x minus 3/2 plus 1/2 cosine of 2x. All right, I think I'm finally ready to integrate this thing. It's taken a while, but I'm there. All right, so the integral of secant squared is tangent. The integral of 3/2 would be 3/2 x. Now this one's going to take a little bit of doing. So what's going to happen here is it's a half. Now the integral of cosine is sine, but the problem is the 2x, right? If you think about U-substitution, I mean, that's kind of what we're doing here. We're doing sort of a baby U-sub. U would be 2x, so du would be 2dx, so we would want a half du, which means you have to put another half in here, right, to be that dx right there. So that means that the final answer would be equal to the tangent of x minus 3/2 x plus 1/4 sine of 2x. Like that. Now, what were the techniques you used? Well, of course, we used our quick reference sheet. We will use it all the time. I mean, that's all the integrals we're supposed to know at this point. So, of course, we used our quick integral sheet. We used trig identities, several of them, in fact. The half angle identity, we used the secant identity, then we used a little bit of U-sub actually at the end right there. That's technically substitution. And we also used expanding. We actually, in two different places, expanded our numerator. Right at the very beginning when we FOILed out this, right? This original binomial squared, and we turned it into that. That's expanding the numerator. And then we also did it, well, it's sort of separating the numerator right here. When we went from this piece to this piece, we also separated the numerator. So we actually used several things. And that's the way, real integration problems work. I mean, if you're going to do integration by hand analytically, you're going to be combining together all sorts of different ideas, all sorts of different formulas. That's the nature of the beast.